Hello, ladies and gentlemen. Mr. Donahue here with some first quarter review for Regents. Hopefully you're using this to study from for the upcoming test. And you can find these problems on my blog, answers there as well. But I figured I'd go through and give you some explanations to them. So which of the following formulas represents a mixture? All right, so the thing that we're going to look at here is the phase in parentheses that they tell us. Remember, solid is an S, liquid is L, gas would be G, and AQ means aqueous, which means it's in water, which means it's a mixture because it's mixed together. So it would have to be choice B. Which of the following elements is calculated, or which value of an element is calculated using both mass and relative abundance of each naturally occurring isotope? That is the atomic mass. If you guys remember the formula, I call it the WAM, the weighted average mass, equals the percent times the mass over 100 plus, in parentheses, the same thing, but for the next isotope, so on and so forth. All right. 3, which of the following statements describes a chemical property of bromine? So chemical property, we're talking about reactions. Those are chemical things. Oxide formulas for when it reacts with oxygen. All right. Changes from liquid to a gas, that's a physical thing. Reddish brown color, that's a physical thing. Soluble in water, that's a physical thing. Combines with aluminum to produce a new compound. That is a chemical thing. All right. 4. These stupid commas here should be arrows, so that is the reaction. That's where the arrow should be. And the question, which one represents a physical change? So we don't want any new compounds. We want the same stuff that we started with, just in a different phase maybe. Like here, I start with H2O solid, and I end up with H2O liquid. That's just a physical change. So this is our answer. And in B, we have a new compound, so that's a chemical thing. In C, we have a new compound, that's a chemical thing. And same with D, new compound, chemical change. All right, 5, according to the wave mechanical model of the atom, electrons in an atom are located in orbitals outside of the nucleus. That is the answer. They don't travel in defined circles. That was more of a Bohr model thing that looked like planets. They don't have positive charges. Electrons are always negative. Are most likely to be found in the excited state. That's just false. Which conclusion was a direct result of the gold foil experiment? You'll always see this, right? We shot alpha particles at gold foil, and most of it went right through, with some of them deflecting and very few of them bouncing straight back. Most of them went right through. So what's that tell you? It tells you that an atom's mostly empty space with a dense positively charged nucleus. All right, you'll see that on every chem exam ever. All right, diagram below is a bright line spectrum of 4 elements and a bright line spectrum produced by a mixture of those 2 elements. So what ones are in there? The way you're going to figure that out is you're going to look at your mixture and you're going to see what lines match up. So this one matches up with that one. This matches there, so on and so forth. What lines match up? Well, it looks like all of barium's lines match up. So barium must be in it. And now I'm going to look at, well, I got these 2 lines left, and they match up with lithium. So what 2 elements are in there? Barium and lithium, choice D. Which subatomic particles are located in the nucleus of a neon atom? They kind of throw you off with specifying an atom. The same particles are in every nucleus, protons and neutrons, right, with electrons on the outside. What subatomic particle is negatively charged? You got to know that. An electron is negative, a proton is positive, and a neutron is neutral. We haven't talked about positrons at all yet, so you can just ignore that. Which part of helium atom is positively charged? The nucleus. The nucleus has the protons in it, so it is positively charged. Which 2 particles have a mass approximately equal to 1 atomic mass unit? So you got to remember that protons and neutrons have a mass of 1, right? So if we got protons, neutrons, electrons, we got mass and charge. Proton has mass of 1, about. Neutron has mass of 1. Electron's so small that we say it's 0. Charge for protons positive, neutrons neutral, and electron is negative. An atom of potassium 37 and 42 differ in their total number of blank. Well, they're both potassium, so they both have the same number of protons. So we know it can't be that. That's got to be the same, or it'd be a different element. If they have the same number of protons, then they have the same number of electrons. The only thing that can be different is neutrons. That's why it weighs more. That 37 and 42 is telling you their mass. The mass comes from protons and neutrons. So if they're the same element, the same protons, the only thing that can be different is neutrons. 13, the most common isotope of chromium has a mass number of 52. Which of the following notations represents a different isotope of chromium? All right, so you want chromium symbol, and then you put the atomic number, and then up top will be the mass. So the atomic number has to be the same, but the mass can't be 52. It's got to be different than that. So which one is it? Choice A. 14. Which isotopic notation represents an atom of carbon-14? So remember, 14's got to be the mass number up top. So that gets rid of every choice except D. What is the total number of electrons in Mg+2 ion? So you got to look, all right, well, Mg has how many electrons? 12. How did it go to Mg+2? Well, it lost 2 electrons, so there must only be 10 left. Remember, electrons are negative, so if you're losing electrons, you're becoming more positive. Become positive 2, you had to have lost 2 electrons, so you have 10 left. An atom in ground state has 7 valence electrons. An atom could be of which element? So you know it's got to be in group 17 because all those ones have 7 valence electrons. You could look at each individual one and check them out, and it'd be fluorine. Remember, valence electron is the very outermost number. An electron in a sodium atom moves from a 3rd shell to the 4th shell. So we're going from 3 to 4. This change is a result of the atom. Well, if it's going up energy levels, you got to be absorbing energy. All right? So atom was absorbing energy. 18. Light emitted from flames produced when electrons in excited state fall back down at an energy level, right? If we have an electron at a high energy level, it falls back down, and then it'll give off light. So it releases energy and moves to a lower energy state. How many neutrons are there in the most abundant isotope of Te? So to do this, you find Te on the reference tables, and you find its average mass. So it looks like its average mass is 127.6, and then you round it to the nearest whole number. The nearest whole number would be 128. So that's its mass. Well, I look up its atomic number to find out how many protons there are. There's 52. So you do 128 minus 52. You get 76. That's how many neutrons there are. Which one of the following lists of elements from group 2 on periodic tables and range of increasing atomic radius? So you gotta remember it gets bigger as you go to the left. Largest ones are on the left. So we're looking at group 2. Oh, for group 2, the biggest ones are on the bottom. So the size goes up at the bottom, right? Because we're adding more energy levels. So which one follows that pattern? Choice C. Which 2 are associated with metals? Metals like to lose electrons because they have a low electronegativity. So they have low first ionization energy, doesn't take much energy to remove them, and low electronegativity. So it would have to be choice C. Right, 22 and 23. In the year of 2014, this will not be on the quarterly, but it probably will be this topic in the future. So I'll show you how to do it right now. So empirical formula is the most simplified formula, and it wants it for a molecule that has a carbon-hydrogen ratio of 2 to 6. So this would be our formula, 2 to 6, C2H6. Well, that could simplify into CH3 if I divide each thing by 2. So that's my answer. Now for the next one, it's the same thing, right? Same kind of idea. You're going to try and simplify it. It says an empirical formula for a compound with a molecular formula of blank. Well, we got 6, 12, 2, and 2. So we can divide everything by 2. We get C3H6Cl. Which one is that? Choice A. All right, guys. Hope you found that helpful. See you in class.